Solid state. The property of crystalline solid is not A. Anisotropic, B. Isotropic, C. Hard, D. Dense. Solid which are crystalline are hard in nature, dense, more dense than liquid and gas, and they are anisotropic. Anisotropic means there is change in direction of light when it is passed through it. So isotropic is not the property of crystalline solid. Option B is the correct answer. A crystalline solid A changes abruptly from solid to liquid when heated. B has no definite melting point. C undergoes deformation on geometry easily. D has irregular three-dimensional arrangement. E softens slowly. In a crystalline solid, there is perfect arrangement of constant particles only at 0 Kelvin. As the temperature increases, the chance that the lattice site may be unoccupied by an ion increases. As the number of defect increases with temperature, solid changes into liquid. So a crystalline solid changes abruptly from solid to liquid when heated. Diamond is an example of A. Solid with hydrogen bonding, B. Electrovalent solid, C. Covalent solid, D. Glass. Diamond is a strong structure which is allotrope of carbon. It is tetrahedral in nature. It is the hardest substance known. It is covalent solid as there is sharing of bond between carbon atoms in the structure of diamond, and the constituent particles are atoms. So covalent solid is the correct answer. The solid NaCl is a bad conductor of electricity since A. In solid NaCl there is no ions. B. Solid NaCl is covalent. C. Solid NaCl there is no velocity of ions. D. In solid NaCl there are no electrons. So solid NaCl is a bad conductor of electricity because ions are not free to move. So there are stable ions in their constituent position. They are unable to move, because of which they cannot conduct electricity. And NaCl is an ionic structure, ionic solid, not a covalent solid. But the reason for not conduction of electricity is NaCl there is no velocity of ions and there are no free electrons. So option C is the correct answer. Quartz is a crystalline variety of A. Silica, B. Sodium silicate, D. Silica carbide, B. Silicon. Quartz is a covalent crystal formed by sharing of electrons of bonds having framework of silicates or silica, that is three-dimensional network when all four oxygen atoms of each of SiO4 tetrahedrons are shared. So it is a tetrahedron crystalline variety of silica. Option A. Malleability and ductility of metal can be accounted due to A. Capacity of layer of metal ions to slide over the other. B. The interaction of electrons with metal ion in the others. C. The presence of electrostatic force. D. The crystalline structure in metal. When a metal is beaten, it does not break, but it is converted into sheet. It is said to possess the property of malleability. Due to ductile nature, metals can be drawn into wires. These two properties of metals can be accounted due to the capacity of layer of the metal ions to slide over the other. So the capacity of the layer of metal ion to slide over the other is seen because of malleability and ductility. So option A is the correct answer. A crystalline solid have A long range order, B short range order, C disorder arrangement, D none of this. A crystalline solid have regular arrangement of constituent particles. So there is regular arrangement of constituent particles, sharp melting point, and are anisotropic. So these are the properties of a typical solid, and they have long range orders. So option A is the correct answer. Which of the following is an example of ionic crystal solid? A diamond, B lithium fluoride, C lithium, D silicon. LiF, that is lithium fluoride, is ionic crystal solid because of the constituent particle positive and negative ions. Lithium act as a positive ion and fluoride act as a negative ion. This forms a electrovalent bond structure. So this is ionic solid, option B. Rest others are covalent solid. How many lattices are obtained from the different crystal system? A7, B14, C32, D230. There are 14 lattices known as space lattices or brevis lattices. These are different types of solids, rhombic crystals or monoclinic. Different structures are formed. So there in total there are 14 brevis lattices or space lattices. How many molecules are there in a unit cell of sodium chloride? A2, B4, C6 and D8. In NaCl or rock salt, number of sodium ions is equal to 12 at edge centers and 1/4. So they are edge 12 into 1/4. One body centered. So in total it is equal to 4. 12 into 1 by 4 plus 1 body centered, which is equal to 4 atoms of sodium. The number of chloride ions are 8 at the corner. So it will be multiplied by 1 by 8 plus 6 face centered multiplied by half. So in total it is equal to 4 atoms. Thus the formula unit per unit cell is 4. So option B is the correct answer. If A stands for the edge length of the cubic system, simple cubic, body centered and face centered cubic, then the ratio of radii of the spheres in this system will be. So we have to find the radius for SCC. Edge length A is equal to 2r. For BCC, body centered, root 3a is equal to 4r, and for FCC, root 2a is equal to 4r. So the ratio becomes a by 2 is to root 3 upon a by 4 is to root 2 upon a by 4. So accordingly, after arranging these atoms, the ratio becomes option C. The structure of ZnS, that is zinc sulfide, is A body centered cubic, B face centered cubic, C simple cubic, D fluorite structure. Zinc blend, that is ZnS, has FCC type of structure. It is an ionic solid or ionic crystal having 4:4 coordination number. Ionic solid, as zinc is the cationic form and sulfur is the anionic form. Option B is the correct answer. Nickel crystallizes in FCC unit cell with edge length of 0.3524 nanometer. Calculate the radius of the nickel atom. So we have to find the radius in the nickel atom, which is an FCC unit cell. So for an FCC unit cell, D phase is equal to A times root 2, or D is the diameter of the phase, or 4R radius of nickel is equal to A times root 2. Therefore, radius of nickel is equal to A root 2 upon 4. We can write this as root 2 upon 4 into SA edge length is given as 0.3524. On solving this, we get 0.1246 nanometer. Option B is the correct answer. An FCC unit cell of aluminium contains the equivalent of how many atoms? A1, B2, C3, D4. So aluminium being an FCC unit, we can write the corner atoms as 1 by 8 into 8, which is equal to 1. At face centered, we can write as 1 by 2 into 6, which is equal to 3. So in total, the number of atom is 1 plus 3 is equal to 4. So option D is the correct answer. Sodium and magnesium crystallize in BCC and FCC type crystal respectively. The number of atom of sodium and magnesium present in a unit cell of their respective crystal is A 4 and 2, B 9 and 14, C 14 and 9, D 2 and 4. In BCC cell consists of 8 atoms at the corner and 1 atom at the center. So n is equal to 8 into 1 by 8 plus 1, which is equal to 2. The FCC contains 8 atoms at the edge, 8 corners, and 1 atom at each 6 faces. This atom at the face is shared by 2 unit cell. So we can write n as 8 into 1 by 8 at the corner and 6 face atoms shared by 2 unit cell, which is equal to 4. So answer D is the correct option. An AB2 type structure is found in A NaCl, B Al2O3, C CaF2, D N2O. AB2 type of structure is present in CaF2 calcium fluoride. We can see AB2 can be written as A2 plus 2B minus. Similarly, calcium fluoride can be written as Ca2 plus 2F minus. So option C is the correct answer. The number of octahedral site per sphere in an FCC structure is A8, B4, C2, D1. The number of octahedral site is equal to number of sphere in the packing. Therefore, number of octahedral site per sphere is 1 and number of tetrahedral site per sphere is 2. So option D is the correct answer. In a FCC centered cubic lattice, atom A occupies the corner position and atom B occupies the face centered position. If one atom of B is missing from one of the face centered points, the formula of the compound is A2B, B AB2, C A2B3, D A2B5. So we can write this as A at the corner, so 8 into 1 by 8. B occupies the face centered, so we can write this as 5 into 1 by 2. So the formula of the compound becomes A2 and B5. So option D is the correct answer. The fraction of the total volume occupied by the atom present in a simple cube is. So the fraction we can find it is equal to volume occupied by atom in a unit cell divided by volume of unit cell. So this is equal to 4 by 3 pi r cube divided by a cube. For simple unit, a is equal to 2r. So we can write this as 4 by 3 pi r cube divided by 8r cube. Substituting a is equal to 2r. So our solutions become 4 pi by 24, which is equal to pi by 6 for a simple unit cell. Option A is the correct answer. An ionic compound has a unit cell consisting of A ions at the corners of the cube and B ions on the center of the face of the cube. The empirical formula of the compound would be AAB, BA2B, CAB3, DA3B. Ion are at the A ions which are at the 8 corners of the cube. A at the corner. Therefore, number of ions A in a unit cell is equal to 8 by 8, which is equal to 1. B ions are at the face centered, so there are 6 faces. Therefore, it share a unit cell in 6 by 2, which is equal to 3. Thus, the formula becomes A, B thrice. So, option C is the correct option. Percentage of the free space in a cubic closed packed structure and its body centered place structure are respectively. So for FCC or CCP closed packed cubic structure, 4R is equal to root 2 times A. Therefore, the fraction of atom is equal to n into 4 by 3 pi r cube divided by A cube. We can write n equal to 4, A is equal to 2 root 2 r. Next fraction is equal to 4 into 4 by 3 pi r cube, and substituting A as 2 root 2 r by cube. So the total fraction is equal to 74% for FCC. So the free space is equal to 100 minus 74, which is 26%. Similarly, finding for BCC structure, 4R is equal to root 3 times A. So our fraction becomes 2 into 4 by 3 pi r cube divided by 4 by root 3 r cube. So the fraction is equal to 68%. So the free space is 100 minus 68 equal to 32%. So 26 and 32%. Option C is the correct answer. 3 element ABC crystallizes into a cubic solid lattice. Atom A occupy the corner, B atom the cube centers, and the C atoms the edge. The formula of the compound is number of atoms A per unit cell is equal to 8 into 1 by 8, which is equal to 1. Number of B atom per unit cell, which is body centered, so it is 1. Number of C atom in a unit cell, which is face centered, edge centered, so it is equal to 12 into 1 by 4. There are 4 edges shared by unit cell, so it is equal to 3. So the formula of the compound become ABC thrice. So option C is the correct answer. The edge length of a unit cell of metal having molecular weight 75 gram per molecule is 5 angstrom, which crystallizes in a cubic lattice. If the density of 2 gram per cubic centimeter, then the radius of the atom is given answer in picometer. So We know that density or specific gravity, mostly density is equal to ZA upon NV. Z is equal to density into N into V upon A. Substituting the values, we know that density is equal to 2 gram centimeter. 2 into N is the Avogadro number, 6 into 10 raised to 23. Volume is equal to 5 into 10 raised to minus 8 cube, as it is angstrom unit, divided by 75 as the molecular weight. On solving this, we get N is equal to 2, R is equal to root 3 upon 4A. So, root 3 upon 4 into 5, as A is the edge length. So, it is equal to 2.165 angstrom. So this is our radius. We can write this in picometer. R is equal to 216.5 picometer. Converting angstrom into picometer. So option A is the correct answer. An element occurring in the BCC structure has 12.05 into 10 raised to 23 unit cells. The total number of atoms of the element in those cells will be. BCC structure has 2 atoms in per unit cell. So the number of atom becomes 12.08 into 10 raised to 23 atom unit cell into 2, which is equal to 24.16 into 10 raised to 23 atoms. So option A is the correct answer. The number of unit cell in 58.5 gram of NaCl is nearly A 6 into 10 raised to 20, B 3 into 10 raised to 22, C 1.5 into 10 raised to 23, D 0.5 into 10 raised to 24. So 58.5 grams of NaCl is equal to 1 mole, which is equal to 6 into 10 raised to 23 NaCl units. 1 unit cell contains 4 NaCl. Hence, number of unit cell present is equal to 6.023 into 10 raised to 23 divided by 4 equal to 1.5 into 10 raised to 23. So, option C is the correct answer. EB crystallizes in a body-centered lattice with edge length A equal to 387 picometer. The distance between two positively charged ions in the lattice is A 330 picometer, B 335 picometer, C 250 picometer, D 200 picometer. For BCC structure, R plus, that is positive ion, and radius of negative ion is equal to root 3A upon 2. Therefore, the distance between positively charged plus negatively charged is equal to root 3 upon 2 into 387 picometer. So, this is equal to 335 picometer. Option B is the correct answer. The radii of sodium and chloride ion are 95 picometer and 181 picometer respectively. The edge length of NaCl unit cell is. In FCC lattice, the distance between the cation and anion is equal to the sum of their radii, which is equal to half of the edge length of the unit cell. So we can write this as sum of the radii of cation and anion is equal to A by 2 half of edge length. R plus is given as 95 picometer and anionic radii as 181 picometer. So edge length is equal to 2R plus 2R minus. So we can write this as 2 into 95 plus 2 into 181 picometer, 190 plus 362 picometer, which is equal to 552 picometer. Option C is the correct edge length. A solid has a structure in which W atoms are located at the corners of the cubic lattice, O atoms at the center, and sodium atoms at the center of the cube. The formula for the compound is, so we know that W atoms are located at the corners, O at the edges, and sodium atoms, Na atoms at the center of the cube. In a unit cell, W atom is equal to 1 by 8 into 8 is equal to 1. O atoms is equal to 1 by 4 into 12 is equal to 3. And sodium atoms at the center of the cube is equal to 1. So ratio is W is 2, that is tungsten into oxygen is to sodium is equal to 1 is to 3 is to 1. So we can write this as NaWO thrice. Option B is the correct answer. In a solid AB having NaCl structure, A atom occupy the corner of the cubic unit cell. If all the face-centered atoms along one of the axes are removed, then the resultant stoichiometry of the solid is. As we know, there are 6 face-centered atoms. So, removing along one axis, so there will be removal of 2 A atoms as there are 3 axes. So, A atoms becomes 1 by 8 into 8 corner atoms, and these are face atoms. So, it is equal to 3. So, in total, A atom is equal to 3. Now B atom is equal to, per unit cell, 12 into 1 by 4 edge atoms plus 1 body center atom. So it is equal to 4. So B is equal to 4 atoms. So answer is A3, B4. Option D is the correct answer. A solid compound XY has NaCl structure. If the radius of the cation is 100 picometer, the radius of anion will be. So the radius of NaCl structure ratio crystal is NaCl radius of cation upon radius of anion is equal to 0.414. Therefore, radius of cation is equal to 100 upon 0. This is radius of anion. Radius of anion is equal to 0.414, which is equal to 241.5 picometer, the radius of anion. So option A is the correct answer.